Hello everyone, welcome to the session for motion and time. This is the third session. We've already done two sessions before this. So before we proceed further, let's just have a quick recap of what we have studied in the previous class. So in the last session, we saw how do we measure time. We saw how do we measure speed. We also saw what are the units of time and speed. The unit of time we saw was seconds. It could have been minute. It could have been hours, and it could have been any such unit which would measure time. And then we saw the units of speed uh, were meter per second. It could have also been kilometer per hour and other such units. Then while we were wrapping up the session, we were studying about a scenario wherein Paheli went for a picnic and she took some odometer readings to measure distance, and she took some readings of the time intervals wherein she measured the time in which these distances were covered. Um, those readings can be seen here. Uh, the time intervals is shown in the first column, the odometer readings are shown in the second column, and the distance from the starting point is shown here. So if you subtract the next odometer reading from the first odometer reading, it gives you the distance covered. So you start with 0 kilometers, then in the next half an hour, the bus covered 20 kilometers. In the next half an hour again, the bus covered 20 more kilometers, so a total of 40 kilometers was covered. In the next half an hour, again, the bus covered 20 more kilometers. So in total, 60 kilometers were covered. And here uh, we see that a total of 80 kilometers have been covered here. So going forward, uh, let's see the next topic, distance in graph, distance time graph. But before we do that, I just want to draw your attention to one table that we are yet to look at from the last session, and this is this table. So what this table uh, tells us to do is it tells us to convert the speed which is given here in kilometers per hour into meter per second. And how do we do that? So what we have here is the speed of a falcon. A falcon is a sort of a bird. ये एक चिड़िया टाइप होती है. uh, और उसकी स्पीड मान लो in kilometers per hour it's 320. So how do you measure its speed in meters per second? So what you do is you convert kilometers into meters. So 1 kilometer is 1,000 meters, and you convert 1 hour into seconds. So 1 hour is 60 minutes, and then 1 minute is 60 seconds, right? So 1 hour is 60 into 60 seconds. Okay, so instead of kilometer per hour, what you write? You write 1,000 meters upon 60 into 60 seconds, and this is multiplied by 320. So if you multiply 320 by this unit, what would you get? You would get the speed in meters per second, which can easily be calculated if you kind of reduce this fraction to the lowest form, and it's simple mathematics from here on. So you can see it's 3200 upon 36, and then if you reduce it further, what will you get? So if you reduce it by 4, and again if you reduce it by 4, so you get 800 here, and you get 9 here. So 800 divided by 9 is 88.89, right? So this is your speed in meters per second. Now let's take the next one. What happens is we take this 112, and then again what do we do? It's in kilometers per hour. So we again reduce it to meters, and then we reduce this to seconds, and then we multiply it by 112 to get the answer after the calculation. So what is happening here? What are we saying? We are actually converting kilometers into meters and hours into seconds. So The simplest thing that is happening here is a repetitive step. Each time you convert kilometers per hour into meters per second, what you're doing, you are actually multiplying it by 1000 and then you're dividing it by 3600. So we can generalize to say that each time that you convert meter per second, you convert kilometers per hour into meters per second. What do? You multiply whatever the unit is, which is given in kilometers per hour, by 1000 upon 3600, or by 5 upon 18. So if you're given, let's say, 18 kilometers per hour, how would you get it into meters per second? You will just multiply it by 5 upon 18, which is 5 meters per second. Conversely, if you are ever given something in meters per second, how would you convert it into kilometers per hour? So what you would do here is you would do the same thing. 1 meter is equals to 1 upon 1000 kilometers, and 1 second is equals to 1 divided by 3600 hours. Okay, and you take it to the numerator. So what do you get it? 3600 upon 1000, which is equal to 18 upon 5. So if you are ever given uh, a speed in meters per second, how would you convert it into kilometers per hour? You just multiply this by 18 upon 5. So 5 into 18 upon 5 is 18 kilometers per hour. So you can see that 18 kilometers per hour is 5 meter per second. 5 meters per second is 18 kilometers per hour. And that's what we were seeing in the previous calculation as well, wherein we saw that 18 kilometers per hour was 5 meter per second and 5 meters per second was 18 kilometers per hour. So the bullet point to note here is that if you want to convert kilometers per hour into meters per second, you multiply by 5 upon 18, right? And if you want to convert meters per second into kilometers per hour, what do? You multiply by 18 upon 5. It's as simple as that. Okay. So this is what we missed in the previous class. And if you are looking for answers here, it's simple mathematics. You just multiply each one of these with 5 upon 18 to get the speed in meters per second. Okay, so let's move forward to learning how we plot graphs for today. So let's begin. You might have seen that newspapers, magazines, etc. present information in various forms of graphs to make it interesting. The type of graph shown in figure 9.8 is known as a bar graph. तो इस फिगर में जो ग्राफ दिखाया हुआ है इसमें ये बार्स हैं, इसको इनको बार्स बोलते हैं, तो इसको एक बार ग्राफ बोलते हैं. Another type of graphical representation is a pie chart. हमने कई बार ऐसे देखा होगा, एक ग्राफ ऐसे गोल बना रहता है, इट्स लाइक अ पाई, राइट, जिसमें आपको बताते हैं कि दिस मच परसेंटेज एक्स का है, दिस मच परसेंटेज वाई का है, और इतना परसेंटेज मान लीजिए z का है. So this representation is known as a pie chart. Okay, the graph shown in figure 9.10 is an example of a line graph. So the third type of graph that you can usually see is the line graph, and we'll see the figure 9.10 just in a second. The distance time graph is a line graph. तो distance time graph जब हम बनाते हैं, we draw it as a line graph. Let us learn to make such a graph. So हम सीखते हैं कि ये ग्राफ कैसे बनता है. So this is the pie chart that we were talking about, and this is a line graph which in which you can see that there's a line connecting the dots here. So this is a line graph. So as a next exercise, what you can do is you can take a graph paper, draw two perpendicular lines to each other on it as shown in figure 9.11. तो यहाँ पे आपके रेफरेंस के लिए एक फिगर दी गई है 9.11. तो आप एक ग्राफ ले सकते हैं, उसमें ऐसा एक फिगर बना सकते हैं और इसमें आपको कुछ पॉइंट्स दिख रहे होंगे y 0 और y डैश, या फिर y o और y डैश, and then x o and x dash. Okay, so here what happens is this is a graph and these are the important lines y o y dash x o and x dash. So let's see what these lines actually mean. So when you've drawn two perpendicular lines are lines which are at 90 degrees to each other. Okay, mark the horizontal line as x o and x dash. तो आपने देखा होगा कि जो horizontal line थी वो ग्राफ पे कैसे मार्क थी, x o and x dash. इसको horizontal line बोलते हैं और इसको vertical line बोलते हैं. And similarly mark the vertical line as y o o dash. तो ये जो x o o dash थी horizontal line, this is called the x axis, and the y o o dash which is the vertical line is called the y axis. So let's mark this as y o and y dash. This is your x axis and this is your y axis. And the center point, the point of intersection of x o x dash and y o y dash is known as the origin. तो ये जो आपका बीच वाला पॉइंट होता है जहां पे ये दोनों एक्सिस आके मिलते हैं, this is called the origin. The two quantities between which the graph is drawn are shown along the two axes. We show the positive values on the x-axis of along OX. Similarly, the positive values on the y-axis are shown along the OY. तो इसमें there are two things to consider कि हमें जिस भी quantities के बीच में ग्राफ बनाना रहता है, उन दो quantities को हम x और y पे represent करते हैं. Okay, and the second thing is that जो positive values रहती हैं उनको हम OX इस एरिया में रखते हैं, इस एरिया में नहीं, और जो y की पॉजिटिव y एक्सिस पे पॉजिटिव वैल्यूज हैं वो हम इस एरिया में रखते हैं, नॉट इन दिस एरिया. ओके, सो दिस इज योर दिस इज योर positive and this is your negative. This is your positive area for value representation. All your positive values are here and all your positive values are here. None of the x-axis positive values are here. यहाँ पे negative values आती हैं और फिर y-axis की negative values यहाँ पे आती हैं. Okay, so keep this in mind while we go forward. So what did we learn so far? The x-axis, the y-axis, the positive values are represented on the OX and OY side of the graph, and lastly the center point is called the origin. Also remember that if you're talking about one axis, the spelling is AXIS, but if you're talking about two axes, the spelling is AXES. So this is the plural for axis. In this chapter, we shall consider only the positive values of the quantities. तो इस चैप्टर में हम सिर्फ और सिर्फ पॉजिटिव वैल्यूज पढ़ेंगे जो कि इस तरफ आएंगी और y एक्सिस के लिए ऊपर की तरफ आएंगी. So this pink area for you will have all the positive values. So, and in this chapter, we will only study the positive values. Therefore, we shall use only the shaded part of the graph shown in figure 9.11. Okay. And then let's begin for what was happening in the previous example. Bujo and Paheli found out the distance traveled by a car and the time taken by it to cover that distance. The data is shown in table 9.6. So let's take another example here. What is happening is that Bujo and Paheli, they've seen a car and the distance traveled by the car is 0 kilometers in 0 minutes, 1 kilometer in 1 minute, 2 kilometers in 2 minutes, 3 kilometers in 3 minutes, 4 kilometers in 4 minutes, and 5 kilometers in 5 minutes. So what do we do here? You can make the graph by following the steps given below. Draw two perpendicular lines to represent the two axes and mark them as OX and OY as in figure 9.11. तो आप क्या करोगे? You'll draw two perpendicular axes. एक ये हो गया और एक axis ये हो गया. So this becomes your OX and this becomes your OY. Okay, and so we marked it as OX and OY. Then what do? We decide the quantity to be shown along the x-axis and that to be shown along the y-axis. Okay, so we decide हमें x-axis में क्या दिखाना है and what do we have to show in y-axis. And in this case, what do we show on the x-axis? We show time along the x-axis and we show distance along the y-axis. तो यहाँ पे हम क्या करते हैं? x-axis के नीचे हम time दिखाते हैं और y-axis के नीचे हम distance दिखाते हैं. Okay, so y-axis is for distance and x-axis is for time. Next, what do we have to do? We have to choose a scale to represent the distance and another to represent the time on the graph. For the motion of a car, the scales could be time. For time, what should be the scale? 1 minute is equals to 1 centimeter. And for distance, 1 kilometer is equals to 1 centimeter. तो यहाँ पे ध्यान रखने वाली बात क्या है कि जो आपका ग्राफ रहता है, that's just a sheet of paper. वो हो सकता है 10 सेंटीमीटर्स का हो, 20 सेंटीमीटर्स का हो, that's it, right? ऐसा आपका ग्राफ रहता है, ठीक है? And it's a piece of paper which is 10-20 सेंटीमीटर्स. अब आप इसमें 1 किलोमीटर, 2 किलोमीटर, 10 किलोमीटर इतना लंबा डिस्टेंस कैसे दिखाओगे, राइट? या आप इसमें मिनट्स और टाइम कैसे दिखाओगे? सो व्हाट हैपेंस इज हम हर एक सेंटीमीटर को कुछ यूनिट में बांट देते हैं. फॉर एग्जांपल लेट्स से ये हमारा टोटल 20 सेंटीमीटर है, तो हम मान लेते हैं कि 1 सेंटीमीटर अगर हम ऊपर जाएंगे तो हमने 1 किलोमीटर कवर कर लिया ग्राउंड पे. अगर हम 2 सेंटीमीटर ऊपर जाएंगे तो हमने 2 किलोमीटर कवर कर लिए. 3 सेंटीमीटर ऊपर जाएंगे तो हमने 3 किलोमीटर कवर कर लिए. ऐसे ही हम अगर 1 सेंटीमीटर इधर मूव करेंगे तो हमने 1 मिनट टाइम स्पेंड कर दिया. अगर हम 2 सेंटीमीटर चलेंगे तो हमने 2 मिनट्स टाइम स्पेंड कर दिए. अगर हम 3 सेंटीमीटर चलेंगे तो हमने 3 मिनट स्पेंड कर दिए. दिस यूनिट कैन बी एनीथिंग. ओके, सो दिस इज हाउ यू डिसाइड द स्केल ऑफ द ग्राफ. तो यहाँ पे इन्होंने क्या किया कि इन्होंने 1 सेंटीमीटर को 1 मिनट ले लिया, तो टाइम हो गया हमारा मिनट्स में और डिस्टेंस हो गई हमारी किलोमीटर्स में. ओके, 1 सेंटीमीटर इज 1 मिनट, 2 सेंटीमीटर इज 2 मिनट्स, 3 सेंटीमीटर इज 3 मिनट्स, 4 सेंटीमीटर इज 4 मिनट्स, 5 सेंटीमीटर इज 5 मिनट्स, 6 सेंटीमीटर इज 6 मिनट्स. Similarly, 1 centimeter is 1 kilometer, 2 centimeters is 2 kilometers, 3 centimeters is 3 kilometers, 4 centimeters is 4 kilometers, 5 centimeters is 5 kilometers. Okay, so this is how you mark your graph. This is 1, this is 2, this is 3, 4, 5. Again, 1 minute, 2 minutes, 3 minutes, 4 minutes, 5 minutes, and 6 minutes. Okay, so this is your markings on the graph. Now, next what they're doing here is mark the values for time and distance on the respective axis according to the scale you have chosen. तो हम अपने स्केल के हिसाब से मार्क कर देंगे अपनी वैल्यूज. फॉर द मोशन ऑफ द कार मार्क द टाइम 1 मिनट, 2 minutes on the x-axis from the origin O. Similarly, mark the distance 1 किलोमीटर 2 किलोमीटर ऑन दी वाई एक्सिस। तो हम ये ऑलरेडी कर चुके हैं, डिस्टेंस 1 किलोमीटर 2 किलोमीटर मार्क कर दिया और टाइम 1 मिनट 2 मिनट यहाँ पे मार्क कर दिया। नाउ you have to mark the points on the graph paper to represent each set of values for distance and time. Observation recorded at serial number 1 in table 9.6 shows that at time 0 the distance moved is also 0. तो हमने टेबल पे क्या देखा था कि 0 टाइम पे 0 डिस्टेंस मूव किया था हमने, विच इज ओके। तो हमने ये पॉइंट मार्क कर दिया, 0 टाइम पे 0 डिस्टेंस। नेक्स्ट, the point corresponding to this set of values on the graph will therefore be the origin itself. तो वो origin पे ही ये point lie करेगा। After 1 minute, 1 मिनट बाद क्या होता है? After 1 minute, the car has moved a distance of 1 kilometer. To mark this set of values, look for a point that represents 1 minute on x-axis. तो हमने कहा कि 1 मिनट में कार 1 किलोमीटर चली, तो 1 मिनट पहले है कहाँ पे ग्राफ पे? This point. Okay. So this is the uh, point which represents 1 minute. Then draw a line parallel to the x-axis. Draw a line parallel to the y-axis at this point. तो इस point में हम एक line draw करेंगे which is parallel to the y-axis. मान लीजिए ये हमने एक parallel line draw कर दी, okay, which is parallel to the y-axis. Then draw a line parallel to the x-axis from the point corresponding to distance 1 kilometer y-axis. तो हमने ये देखा था कि एक मिनट में कितना डिस्टेंस कार गई थी? 1 किलोमीटर। तो हम 1 किलोमीटर पे आते हैं और एक्स एक्सिस के पैरेलल एक लाइन ड्रॉ कर देते हैं। ओके, सो व्हाट इज दिस देन? दिस इज द पॉइंट कि हमें बताती है जहां पे ये दोनों लाइंस मिलती हैं कि 1 मिनट में उसने कितना डिस्टेंस ट्रेवल किया? 1 किलोमीटर। 1 किलोमीटर ट्रेवल करने में कितना टाइम लगा? 1 मिनट। ठीक है, सो दिस पॉइंट ऑफ इंटरसेक्शन जहां पे ये दो लाइंस मिलती हैं, ये हमें अपना रिजल्ट देता है। The point where these two lines intersect, जहां पे ये दो लाइंस मिलती हैं, represent this set of values on the graph. तो 1 मिनट में 1 किलोमीटर कहाँ पे हमें दिखेगा? यहाँ पे। Similarly, mark on the graph paper the points corresponding to different set of values. तो हम फिर अलग-अलग values के लिए mark करते हैं। 2 मिनट में वो कितना गया था? It went 2 kilometers. 3 minutes में it went 3 kilometers. 4 minutes में it went 4 kilometers. ठीक है, तो आपको एक पैटर्न दिख रहा है। नाउ इफ यू जॉइन ऑल दीज पॉइंट्स you get a straight line. Okay, so this is a straight line, and that's why we are seeing that this represents the points which is shown in the table. Also, if you see a line, what does this show? This is a line graph. Okay, so after we mark the corresponding values for different set of values, what do we see? We see a graph like this, 9.12. Okay, figure 9.12 shows the set of points on the graph corresponding to the position of the car at various times. तो 9.12 हमें क्या बता दिया? The position of the car at various times. Join all the points on the graph as shown in figure 9.13. It is a straight line. This is the distance time graph for the motion of the car. तो हम वही बोल रहे थे कि this is a line graph with a straight line. And what is this graph called? It's called the distance time graph. Why distance time graph? Because the axes here are represented by distance and by time. Okay, so I think this is clear. If the distance time graph is a straight line, it indicates that the object is moving with a constant speed. However, if the speed of the object keeps changing, the graph can be of any other shape. तो यहाँ पे क्या हो रहा है कि हम एक कांस्टेंट यूनिफॉर्म मोशन देख रहे हैं। क्या देख रहे हैं? 1 मिनट में 1 किलोमीटर, 2 मिनट में 2 किलोमीटर, 3 मिनट में 3 किलोमीटर. So what is this? There's a constant चेंज इन डिस्टेंस आफ्टर अ कांस्टेंट चेंज इन टाइम इंटरवल। एक हर एक मिनट में वो 1 ही किलोमीटर जा रहा है, एंड दैट्स व्हाई इट्स अ स्ट्रेट लाइन। अगर ऐसा नहीं होगा, if in one minute it goes 1 kilometer, in 2 minutes it goes 3 kilometers, in 3 minutes it goes 10 kilometers, so this graph can be even of a different shape. Okay, so I think that point is kind of clear. Let's move forward. All right, so generally the choice of scales is not as simple as in the example given in figure 9.12 and 9.13. तो स्केल्स अभी तो हमने बहुत आसानी से ले लिए थे कि 1 किलोमीटर इज इक्वल्स टू 1 सेंटीमीटर और 1 मिनट इज इक्वल्स टू 1 सेंटीमीटर। लेकिन इतना सिंपल कभी कभी नहीं होता। वी मे हैव टू चूज टू डिफरेंट स्केल्स टू रिप्रेजेंट द डिजायर्ड क्वांटिटीज इन द एक्स एक्सिस एंड वाई एक्सिस। लेट अस ट्राई टू अंडरस्टैंड दिस प्रोसेस विद एन एग्जांपल। तो हो सकता है कि हमें अलग अलग वैल्यूज लेनी हो ये स्केल्स को डिफाइन करने करने के लिए, और हमें इसको एक एग्जांपल से समझते हैं। लेट अस अगेन कंसिडर द मोशन ऑफ द बस दैट टुक पहेली एंड हर फ्रेंड्स टू द पिकनिक। तो हमने इस सेशन के स्टार्टिंग में देखा था वो पिकनिक वाले एग्जाम्पल, जिसमें हर आधे घंटे में उसने ओडोमीटर रीडिंग ली थी और हर आधे घंटे में वो 20 किलोमीटर आगे बढ़ रही थी। ठीक है, तो द डिस्टेंस कवर्ड एंड द टाइम टेकन बाय द बस आर शोन इन फिगर, आर शोन इन टेबल 9.5। तो आपको अगर वो टेबल 9.5 पहले की याद होगी तो उसमें डिस्टेंस और टाइम्स दिखाए गए हैं। दिस टेबल, ओके, आफ्टर एवरी हाफ एन आवर बस 20 किलोमीटर जा रही है। ओके, so just keep this table in mind. Right, the distance covered, the total distance covered by the bus is 80 kilometers. If we decide to choose the scale, a scale 1 kilometer is equals to 1 centimeter, we shall have to draw an axis of length 80 centimeter. तो ऐसा क्यों है? मान लीजिए आपने एक स्केल बनाया, आपने एक ग्राफ बनाया, और आपका ग्राफ पेपर कितना है, 20 सेंटीमीटर का या 25 सेंटीमीटर का एक पेज है। अब आपने कह दिया कि 1 किलोमीटर हम 1 सेंटीमीटर से रिप्रेजेंट करेंगे। तो 1 सेंटीमीटर आपने मार्क कर दिया 1, फिर नेक्स्ट सेंटीमीटर आपने मार्क कर दिया 2, एंड दिस इज इन किलोमीटर्स। लेकिन यहाँ पे बस कितना जा रही है, 80 किलोमीटर। तो आपको कहाँ तक जाना पड़ेगा, 80 सेंटीमीटर तक जाना पड़ेगा 80 किलोमीटर दिखाने के लिए। लेकिन आपका ग्राफ पेपर तो है सिर्फ और सिर्फ 20 सेंटीमीटर का या 25 सेंटीमीटर का। तो अब आप क्या करोगे? सो वॉट यू डू इज, इंस्टेड ऑफ डिफाइनिंग इट एज 1 किलोमीटर इक्वल टू 1 सेंटीमीटर, आप क्या सोचोगे, यार मैं ऐसा करता हूँ, आई या मैं ऐसा करती हूँ, आई कैन डिफाइन 10 किलोमीटर एज 1 सेंटीमीटर। मैं 1 सेंटीमीटर को 10 किलोमीटर जितना दिखाती हूँ। तो अब मैं क्या करूंगी कि एट 1 सेंटीमीटर आई राइट 10 किलोमीटर, at 2 centimeters I'll write 20 kilometers, at 3 centimeters I'll write 30 kilometers, at 4 centimeters 40 kilometers, and so on. Okay, so now what you've done, you've adjusted your scale according to the quantities that were given। जो आपको ये quantities दी हुई थी ना 80 किलोमीटर की, ओके, उसके हिसाब से आपने अपने स्केल को एडजस्ट किया। ओके, सो वो वही बात वो यहाँ पे बोल रहे हैं कि वी हैव टू ड्रॉ एन एक्सिस ऑफ लेंथ 80 सेंटीमीटर। 80 सेंटीमीटर तो लेकिन हमारे पास शायद हो भी ना, दिस इज नॉट पॉसिबल ऑन अ शीट ऑफ पेपर। On the other hand, a scale of 10 kilometers equals to 1 centimeter would require an axis of only 8 centimeter. This scale is quite convenient. So अगर आप 10 kilometers equals to 1 centimeter लो, तो आपका 8 सेंटीमीटर में सारा काम निपट जाएगा और ये स्केल बहुत कन्वीनियंट रहेगा, बहुत सही रहेगा। However, the graph may cover only a small part of the graph paper. Some of the points to be kept in mind choosing uh, while choosing the most suitable scale for drawing a graph are, तो एक स्केल चूज करते समय आप क्या क्या पॉइंट्स ध्यान में रखें। फर्स्ट पॉइंट, द डिफरेंस बिटवीन द हाईएस्ट एंड द लोएस्ट वैल्यूज ऑफ ईच क्वांटिटी। तो सबसे हाईएस्ट वैल्यू जैसे कि फॉर एग्जांपल यहाँ पे थी 80 किलोमीटर और लोएस्ट वैल्यू क्या थी 0 किलोमीटर। ठीक है, क्योंकि हम स्टार्ट 0 किलोमीटर से ये थे। सो यू शुड कीप इन माइंड द हाईएस्ट एंड द लोएस्ट वैल्यूज, देन you should keep in mind the intermediate values of each quantity so that with the scale chosen it is convenient to mark the values on the graph. तो यहाँ पे इंटरमीडिएट वैल्यूज क्या थी, पहले मतलब इंटरमीडिएट वैल्यूज जो भी इसके बीच में आती हैं, यानी कि 20 किलोमीटर, 40 किलोमीटर, 60 किलोमीटर, ऑल दीज आर इंटरमीडिएट वैल्यूज। तो अब अपना ग्राफ का स्केल ऐसे, जैसे कि अभी हम ऐसे भी चूज कर सकते थे कि 8 किलोमीटर इज इक्वल टू 1 सेंटीमीटर, तो हम इसको लिखते 8, फिर इसको लिखते 16, फिर इसको लिखते 24, फिर 32। लेकिन उसमें क्या होता है कि इफ वी हैड टू शो 20 किलोमीटर ना यहाँ पे, ठीक है, तो हमें दिखाने में दिक्कत हो जाती है, बिकॉज 8 यहाँ है, 16 यहाँ है, 24 यहाँ है, फिर हम 20 बीच में ढूंढते, राइट। सो इट्स बेटर दैट वी शो इट एज 10 हियर, 20 हियर, 30 हियर, 40 हियर, और फिर जब हम 20 को ढूंढने जाएंगे अपने वाई एक्सिस पे तो हमें सीधा सीधा मिल जाएगा। सो along with the maximum and the minimum value, we should also keep in mind the intermediate values while choosing the scale. Next, to utilize the maximum part of the paper on which the graph is to be drawn. तो हम ऐसा भी ना करें कि हम यहाँ पे चूज कर ले अपने कन्वीनियंस के हिसाब से, मान लीजिए 40 किलोमीटर इज इक्वल टू 1 सेंटीमीटर, तो आपका क्या होगा, सिर्फ 2 सेंटीमीटर में पूरा ग्राफ निपट जाएगा। लेकिन आपका ग्राफ तो है 20 सेंटीमीटर का और आपने सिर्फ 2 सेंटीमीटर में इतना सा बना के ग्राफ निपटा दिया। सो दैट इज ऑल्सो नॉट अ गुड वे। सो यू शुड ट्राई टू show your graph in a larger part of your graph sheet so that it is neat and clean, it is large, and it shows clearly the values that you want to represent. Okay, so these are the 3 points that you should keep in mind before you decide on the scale of the graph or the scale of the quantities. Okay, suppose that you are given a graph of paper size 25 into 25, one of the scales which meets the above conditions and can accommodate the data of table 9.5 could be distance is 5 kilometers for 1 centimeter, and time 6 minutes is equals to 1 सेंटीमीटर। ओके, तो 9.5 से जो हम डेटा लेके आए थे, लेट्स से उसमें 5 किलोमीटर्स को हमने 1 सेंटीमीटर मान लिया एंड 6 किलोमीटर्स को हमने यहाँ पे 1 सेंटीमीटर मान लिया। कैन यू नाउ ड्रॉ द डिस्टेंस टाइम ग्राफ फॉर द मोशन ऑफ द बस? इज द ग्राफ ड्रॉन बाय यू सिमिलर टू दैट शोन इन फिगर 9.13? तो हम पहले क्या कर सकते हैं, यहाँ पे we have a graph of 25 centimeter into 25 centimeter. Okay, so what we can do is we can make a y-axis here, an x-axis here. ये y-axis हो गया, ये x-axis हो गया. I'll just improve it for clarity purpose. और मैं इसको actually थोड़ा और बड़ा बना देता हूँ so that it's clear for you people. Right. So this is your y-axis and this is your x-axis. Okay. तो वो यहाँ पे बोल रहे हैं कि आप डिस्टेंस को 1 सेंटीमीटर के डिस्टेंस को 5 किलोमीटर मान लो। सो दिस इज 5, दिस इज 10, दिस इज 15, 20, 25, 30, 35, 40, 45, 50 और आप ऊपर तक ले जाना टिल 80। ओके, और टाइम को आप क्या करो, 1 सेंटीमीटर को 6 मिनट्स मान लो। सो दिस इज 6, दिस इज 12, दिस इज 18, दिस इज 24, 30, 36, 42, 48, 54, 60, which is actually 1 hour. Okay, तो हमने क्या देखा था उसमें कि 30 मिनट्स में बस कितनी गई थी, 20 किलोमीटर, राइट। तो 30 मिनट्स में हमारी बस 20 किलोमीटर गई थी। फिर नेक्स्ट 30 मिनट्स में हमारी बस 20 किलोमीटर और गई थी। ओके, तो 40 किलोमीटर गई थी 60 minutes. Okay. So one point of intersection is this, one point of intersection is this. Okay. और जीरो, मतलब जीरो टाइम में कितना गया था? जीरो. Okay. 0 kilometers. So we started at 8:30. Okay. This is 8:36. This is 8:42. This is 8:48. This is 8:54, and then this is 9 o'clock. Okay. 9 o'clock में वो half an hour में 20 kilometers गया था. Now if you join all these points, we get a graph which is very similar to the graph 9.13. Right. You can see here your graph is very similar to, sorry, this is 9.14. Yeah. Your graph is a linear graph, or you can say it's a straight line graph, very similar to 9.13. Okay. Right. The distance time graphs provide a variety of information about the motion. So the distance time graph, what do? They provide a variety of information about how the motion is happening. Okay. When compared to the data presented by the table. तो टेबल में क्या होता है कि आपको कुछ वैल्यूज दी रहती हैं, लाइक 8 o'clock पे वो या 8:30 पे वो 0 kilometers गया था. आई थिंक 8:30 पे ही द वैल्यू वाज 0 kilometers. 8 o'clock पे it was 0 kilometers. Okay. Yeah. So 8 o'clock it was 0 kilometers, and then 8:30 पे it was 20 kilometers. 9 o'clock पे it was 40 kilometers. So it's giving you time uh, in in gaps. ठीक है. लेकिन अगर आपको इसके बीच में कहीं पे डिस्टेंस ढूंढना हो, लाइक 8:15 पे या 8:45 पे, then you're lost. Okay. So how can you solve this problem? This you can solve it by drawing a graph. तो वही वही चीज यहाँ पे बोल रहे हैं that uh, when compared to the graph gives you a better information when compared to the table. For example, table 9.5 gives information about the distance moved by the bus only at some definite time intervals. वो कुछ definite time intervals में या fixed time intervals में ही आपको information दे रहा है. On the other hand, from the distance time graph, we can find the distance moved by the bus at any instant of time. Suppose we want to know how much distance the bus had moved at 8:15. We mark the point corresponding to the time 8:15 on the x-axis. So this is actually referring to the figure 9.14. I can show you the figure 9.14, but it will be a very good practice if you actually try to plot that graph on your own by choosing a very good scale. So here what we can do is we can choose a scale of uh, let's say half 30 minutes in x-axis. Okay. So this is your, or let's say 15 minutes in x-axis. So this is your 1 centimeter is equals to 8:15. Okay. Then 8:30, 8:45, 9 o'clock, 9:15, 9:30. Okay. And then on the x-axis, on the y-axis, what you do, you take distance with each centimeter is equals to 10 kilometers. So this is 10, this is 20, this is 30, this is 40, this is 50, this is 60, 70, and then 80. Okay. So uh, right, this is what we are doing here. Okay. Now at 8:30 it had moved 20 kilometers. Okay. At 9 o'clock it had moved 40 kilometers. Okay. At 9:30 it had moved 60 kilometers. Okay. So we join all these points to get a distance time graph. It's not a very straight line, but you get the point. Okay. Now, what do you want to do next? You want to find that where was it at 8:15. तो आप 8:15 से क्या करते हो, एक perpendicular draw करते हो इस point पे. Okay. And then from here you draw a perpendicular on your y-axis. Okay. And then what you can do is you can calculate कि 8:15 पे उसने कितना distance move किया था. And this is the power of graph. Okay. We mark. So what do we do? Suppose we want to find the distance moved by the bus at 8:15. We mark the point corresponding to time 8:15 on x-axis. हम पहले 8:15 वाला point mark करते हैं. Suppose this point is A. इसको A mark कर दो आप. Suppose. Okay. Then uh, next we draw a line perpendicular to x-axis or parallel to y-axis. तो x-axis के perpendicular या फिर y-axis के parallel एक line अपने ऊपर draw करी. Okay. Uh, Okay, and then we mark the point T on the graph at which the perpendicular line intersects it. तो ये ग्राफ पे जिस पॉइंट पे इस लाइन को इस ग्राफ को इंटरसेक्ट करता है इसको हमने T मान लिया. नेक्स्ट वी ड्रॉ अ लाइन थ्रू द पॉइंट T पैरेलल टू द एक्स एक्सिस. तो एक हमने नेक्स्ट लाइन बनाई पैरेलल टू द एक्स एक्सिस फ्रॉम पॉइंट T. ओके, वो यहाँ पे आके यहाँ तक ड्रॉ की. दिस इंटरसेक्ट्स वाई एक्सिस एट पॉइंट बी. तो जहाँ पे ये पॉइंट जहाँ पे जिस पॉइंट पे ये वाई एक्सिस को इंटरसेक्ट करेगी उसको पॉइंट बी मान लिया. द डिस्टेंस corresponding to the point B on y-axis OB gives the distance in kilometers covered by the bus at 8:15. तो ये आपका अगर ओरिजिन था, so this distance OB gives you कि ये कितना डिस्टेंस 8:15 तक कवर कर पाया. Okay. Similarly, if you want to find out how much distance it covered at 8:45, what you do is you draw again a perpendicular to x-axis, and then from that point you draw a perpendicular to y-axis, and then you'll get कि वो 8:45 पे उसने कितना distance cover किया, which is from O to let's say D, which is 30 kilometers. How much distance? How much is this distance in kilometers? Can you now help Paheli to find out the distance moved by the bus at 9:45? Can you also find the speed of the bus from its distance time graph? So two things that you have to do here is you have to help Paheli finding out the distance that it covered at 9:45. So at that distance will be 70 kilometers, similar as these examples. Next, what you have to do is you have to find the speed of the bus. So before I find the speed of the bus, I just wanted to show you how they've done it in the book. It's the same thing that we've done here. Okay. Now, how do you find the speed of the bus? After all this study, do not forget the important thing. Uh, and what is the important thing? It's the formula for speed time graph. Okay. So what was the formula? Do not forget the formula for speed. Sorry. Yeah, I wanted to say do not forget the formula for speed, which was the distance covered upon time taken to cover the distance. Now, since equal amount of distance was covered in equal intervals or the motion was uniform, we can take any distance in any time interval. So let's say we take how much distance did it cover in half an hour? It covered 20 kilometers in 30 minutes. Okay, so what's the speed? It is 2 upon 3 kilometers per minute. Okay, now another way to find out this is it. Let's say we take the entire duration of 3 hours. Okay, it started at 8 o'clock. It was 40 kilometers at 9 o'clock, and it was 80 kilometers at 10 o'clock. So sorry, we take the entire duration of 2 hours. So it went 80 kilometers in 2 hours. And 2 hours is how many minutes? 120 minutes. Okay. So what's the speed? 80 kilometers in 120 minutes is 8 upon 12. And then you reduce it further to 4 twos are and 4 3. Okay. So 2 upon 3 meters per second. Okay. Another method of finding it out is how much time did it take to cover 40 kilometers? 1 hour. 1 hour is 60 minutes. Okay. So this is again 2 upon 3. And this is how, no matter how much gap you take, you'll always get the same speed. Why? Because the speed is constant throughout. Okay. You also know that at let's say 8 o'clock, it was at 0 kilometers. At 8:30, it was at 20 kilometers. At 9 o'clock, it was at 40 kilometers. Okay, so now let's say in this half an hour, how much distance did it cover? 20 kilometers. So you can also see like this: 40 minus 20. This is the distance covered, and how much time did it take to cover this distance? 9 o'clock minus 8:30, which is half an hour. So again, 20 upon 30 minutes, which is 2 by 3. Okay, so this kind of ends our chapter here. Let's quickly run through what were the keywords that we used in this chapter. The bar graphs जो हमने अभी देखे थे, जो bars बने हुए थे ऐसे एक ग्राफ में. So we saw bar graphs like this. Okay, we saw different types of graphs. You're familiar with it. Then यूनिफॉर्म मोशन एंड नॉन यूनिफॉर्म मोशन. यूनिफॉर्म मोशन वो जिसमें सेम टाइम इंटरवल, अगर हम कुछ भी टाइम इंटरवल देखें तो उनकी डिस्टेंस कवर्ड सेम रहता है. ओके. ऑक्सिलेशन, we saw what was oscillation. It was the to and fro motion of a pendulum, or it's the periodic motion of an object is called oscillation. Okay. One oscillation कितना है? The complete journey of a pendulum is called one oscillation. Okay. Simple pendulum क्या होता है? This is the diagram of a simple pendulum hanging from a iron bar or whatever, a thread and a bob. Okay. What is speed? Speed is the distance traveled by an object divided by the time taken by it to travel this much distance. Okay. Next, what is time period? So the time taken by uh, the bob or the pendulum to complete one oscillation is called its time period. Okay. Uniform motion we discussed already. And then unit of time. What is the unit of time? Seconds or minutes or hours. Okay. And let's quickly run through also what have you learned in this chapter. The distance moved by an object in a unit time is called its speed. तो एक unit time में हमने जितना भी distance cover किया हो, that is its speed. So I told you what is unit time. One or singular value of a time is called a unit time. So 1 second or 1 minute or 1 hour. And in this singular unit of time, the amount of distance that has been covered by the object, 10 kilometers or 10 meters or 10 centimeters, whatever, is its speed. Okay. The speed of objects helps us decide which one is moving faster than the other. तो हम speeds को compare कर सकते हैं और फिर बता सकते हैं कौन सी तेज चल रही है और कौन सी हल्के चल रही है. But remember that you can only compare speeds with the same units. So you cannot compare 5 meter per second with 4 kilometers per hour. Okay. Or with 10 kilometers per hour. Okay. You can compare these both and you can say 10 kilometers per hour is a higher speed, but you can't compare 5 meter per second and 10 kilometers per hour. Okay. Because 5 meter per second is how many kilometers per hour? Can you calculate? 18 kilometers per hour, which is actually faster than this. So make sure that the units of speed are same. Next, the speed of an object is the distance traveled divided by the time taken to cover that distance. Its basic unit is meter per second. Okay. So in mathematical terms, अगर हम maths के terms में बात करें तो speed की definition क्या है? Distance traveled by the object divided by the time taken to cover that distance. और इसकी unit क्या है? Meter per second. Periodic events are used for the measurement of time. Periodic motion of a pendulum has been used to make clocks and watches. ठीक है? Motion of objects can be presented in pictorial form by their distance time graphs. तो motion of objects को अगर हम एक picture के form में represent करना चाहें, pictorial form means picture के form में या image के form में, तो हम distance time graph के तौर पे उसको represent कर सकते हैं. The distance time graph for the motion of an object moving with a constant speed is a straight line. तो अगर कोई भी object constant speed से move कर रहा होगा तो जो उसका ग्राफ बन के आएगा that will be a straight line. Okay, so in the next session what we'll do is we'll discuss the question and answers for this chapter. So thank you for being here, and if you have any questions, please write it in the comments, and do not forget to like and subscribe. Have a good day. Thank you. Bye bye.